Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a discussion about affordances in software design. So let me introduce the topic really quickly. This is a tweet that I got that brought my attention this week by Andrei Alexandrescu. In case you don't know who Andrei Alexandrescu is, he's a very smart guy. He's been doing a lot of work with C++, wrote one seminal book about C++. And I found this very interesting. He said, I speculate that one reason Python is popular is because it fosters APIs that work just the way someone unfamiliar with them would imagine. You create this object, you call this method, and a good time has been had. For reasons unknown, that's seldom the case with C++ APIs. And then he goes into more details, like even the simplest working are often very surprising. They go like to use the API. It's very important to create a domain first by using an integral C. There can be unlimited domains. Then there is a default domain for historical reasons. You can use the default domain, but it is not recommended because that is not thread safe, and so on. So it goes into a lot of intricacies on how C++ works. And to this I replied, look, I've got two very nice surprises when first learning Python. First, when I didn't know the syntax, I would write the code as I imagined, and it just worked. This was a very good, nice surprise for me. This is one of the reasons I like Python, because it matches my mental model. Second, it was the only language that had CSV processing and unit testing in its standard library. And then I've added, these are just two examples of usability, something I strongly believe should permeate more language and software design. So, and then I got some answers here that, it also has a database and string processing and so on. So you have a bunch of things in Python that basically, when I think about solving problems, I would jump into Python. When I think about dealing with more complex things, with things that require performance, with things that require me to go into more like to create more general libraries, some more elaborate design and so on, C++ is one option. It might not be the first option, but it's one of the options. So in general, my feeling is that C++ makes you feel smart or intellectually superior, while Python helps you solve problems. And the problem here isn't as much that, C++ is a more difficult language, but it has its benefits. You can optimize the memory, you can optimize performance, you can do a lot of very useful stuff in C++. I'm not one of the people who continuously bashes C++. But the key thing here is usability for me. Usability is something that we still have not gotten into our heads that has to be part of software design. Now let me quickly explain what I mean by usability in the context of software design, because it is a bit confusing. I've talked about this before with usable software design, but let me just be clear, or try to be clear about this. When I'm talking about usability of software design, so first of all, I'm talking about the following things. Your code base, I consider that to be the design that you are using as a developer. As a developer, you would go into this code base, make some changes, add some features, or from the outside, use it. And in this case, what we are talking about is, because it's about APIs, Python APIs versus C++ APIs, and not the REST APIs, so not web-based APIs, but more like library APIs, right? How do you use a library? How do you use an existing module from the standard library, for example, things like that. So in this case, you as a developer, you are the user of that library, and you therefore need to add that library as a dependency and start using it. The internals of the library can be very smart. You can do a lot of optimizations, and you can give a lot of options to people on how to use that library depending on their contexts. Like Andrei Alexandrescu was talking about, there are different domains, some of them are thread safe, some of them are not, and so on. So depending on your context, there could be some different ways in which you organize your code. But what is important is to offer an additional, like the default way, which is not necessarily the perfect way, but provide some defaults, some easy to use ways for somebody new to the library who just wants to solve a problem without caring about optimization right now or about all the possible situations right now. One of the key things in software development is that we have a problem, we want to solve that problem, and we try out something small. We see how far it works. We look at what are the differences between what it does and what we want it to do, and then we do some optimizations. We add more features, optimize performance, and so on. And this feedback loop is very important for a smooth and fast development experience. If you make me learn 20 different things before I can actually start solving my problem, that is extremely annoying, slows me down, and just doesn't help in general. So, while maybe this is not the reason why Python is popular, that was just a pretext. What I really want to talk about is about offering these things on top of your APIs. Even if your API is extremely complex, offer some nice defaults. And those defaults are called in UX affordances. Okay, let me quickly go to this. This is the book that basically created the modern UX. It's called The Design of Everyday Things. Highly recommend you to read it. It talks a lot about door handles and stuff like that. And fundamentally, one of the problems with door handles is how do you know whether the door opens inside, so whether you have to pull or to push the door? Do you know this just by using the handle? And on some doors you know, on some others you don't. With a traditional handle, well, you just, move down and push or pull. You never know whether you need to push or pull unless there's some clear signifier near the door itself. And what Donald Norman showed is that you can actually improve this by designing things so that they show you what it's possible. Okay? And this is a best-selling book. And in the book, Donald Norman introduced this term affordance as it applied to design, borrowing James J. Gibson concepts from ecological psychology. Examples of affordances are flat plates on doors meant to be pushed, small finger size push buttons, long and rounded bars we intuitively use as handles. As Norman used the term, the plate or button affords pushing while the bar or handle affords pulling. Norman discussed door handles as length. And so he discusses a bit more about these things. All right, so this is the initial book. Cool. And now let's look at affordances in other domains. There are some different types of affordances: explicit, hidden, and pattern affordances. There are some metaphorical affordances. So there's a bunch of things that you can do. So for example, in UX design on websites, you would have buttons that are temporarily disabled while an action is happening so that you don't push them again, and so on. These are examples of affordances. One thing that I found interesting is this quote. Affordances determine what actions are possible. Signifiers communicate where the action should take place. We need both. So now let's look to some examples of affordances. And one of my favorite examples is how do we use to read a file? Let's say you want to read the full content of a file in a string in memory. How do you do it in your programming language? Just think a bit about this. And this is how we used to do it in Java. So first you needed to create a string builder. Then you needed to, and I could never remember this. So you needed a file reader which reads through the path. And then you had the buffer reader on top of the file reader. And then you have a string, while string equals buffered or read line non-null, which means until the end of the file, buffer append string append /n, cache block to handle the exception, whatever, return builder to string. Oh yeah, because we have the append here. So in order to do this, what you needed is to know about how many things? A string builder, file reader, a buffered reader, the fact that read line returns null for the last line, so for the end of the file. And then, yeah, do some exception processing and so on. Now, is this a correct design? And probably it is, because look, file readers, buffering, these are different concerns from a functional perspective, from a design perspective. It makes sense to have all these things. If you want to optimize, if you have a very large file, if you have a very, or maybe you know you have a small file, or maybe you know that you have a very large file, or maybe you have a binary file. It depends a lot on what you are trying to do, right? So it makes sense to have this separate buffer reader, file reader, and so on. Buffering optimizes certain things. It's a trade-off. It helps you read faster from the file system, but on the other hand, you read in memory more, so you consume a bit more memory while reading, and so on. So there are things here, and you could go into even more detail, like how large should the buffer be, and so on. And I remember doing those things probably, when was this? 20 years ago, in C++, when I was developing for a product that was reading large databases, and basically we had our own database engine, and we were very careful of optimizing all these things depending on the limitations of the hardware at that point in time. So it makes sense if you're trying to do certain things. But then, what is stopping us for having an affordance? And what would be how would an affordance look in this case? Well, there's another language called Groovy, which is built on top of the Java virtual machine. And this is how you read the whole content of a file into a string. You basically do a new file of path to file.txt, and that is all. Now, this might throw an exception, so maybe I need to catch exceptions. This might, maybe I have some issues here, maybe it's not optimal. If I need to specify an encoding, I can do a new file of path to file.getText of UTF-8, for example. Okay? I don't have to know about string builders, about anything. Now, the good news is that Java has also optimized this a little bit. So now we can have things like path file name equals path of, and the path string files string str equals files.read string of file name. And this does exactly the same thing, reads into a string from a file. So this is an example of an affordance. Okay? And how would I use this? As I said before, let's say I want to use this API. Well, first of all, I don't want to use this API. What I want to do is to solve a problem. And my problem involves at some point reading text from a file. Now let's assume that file, I'm still in development or in testing mode. I have 8 gigabytes of RAM. I know that I can load this whole file in memory and nothing will happen, even if the file is 1 gigabyte. All right. Would that be ideal for production? Maybe not. But is this good enough to start developing? Absolutely. So what I really want to do is to do something like read string file name, write my code for processing that file, whatever I need to do, and then give a first solution. And I have the first solution implemented, and now I can look and say, okay, so there are some issues here. This file could be much larger than the RAM that I have. Okay, let's start reading it buffered and so on. Perfectly fine. I can optimize for various scenarios and so on. Absolutely. But first of all, a first iteration when I can actually use an affordance is incredibly useful. Let me give you, so this is one example of affordance. My mental model in this case is kind of like a shortcut. So in the way you would have a shortcut on your desktop towards, or an alias, that maybe would be a better metaphor. Like in Linux systems, you can define aliases for commands. So I could say, instead of git status, which is something I write a lot, I type a lot in the terminal, what I have done is I have git st. So st is an alias for status. I could even go further and have an alias that's just gst, which is an alias for git status. Right? It just helps me solve the same problem by typing less. Same thing with git commit. I have the normal syntax would be git commit, and then the message is optional. And you have to write -m and give a message. I know that I will always commit with a message, so I did an alias that just git commit -m is git CI. So I can write git CI and the message directly. So I have to type less. And you could probably go further and do something like GCI and so on. So this is an option for, it's kind of an alias, right? It doesn't cover all the possible situations that I need, but it covers the most used starting points, let's say. The most used ways in which I start using the library, the API. And having this start is extremely important because it activates iterative incremental problem solving, which is the basis of software engineering. So we've seen this. Now, another type of affordance is adding a fluent interface. Fluent interfaces allow us to build stuff while ignoring some of the intricacies. And one example here is, what if I want to define a regular expression? So I know the concept of regular expressions, but the syntax is slightly different from Java to Python to C++ to Perl to JavaScript to C#. So maybe I know that I need a regular expression. I also know that I need to, I know the concept of regular expression. I know what a regular expression is formed of, but I don't precisely know all the intricacies, all the small differences. And I don't remember right now how to write it in Java, for example, because I've only done it in JavaScript for the past 3 months. Or the last time I did the regular expression was last year. All right, what can I do? I could go to documentation and start looking and test out regular expressions, which is a perfectly valid way of doing. Or I could use something like this, which is my fragment equals b, then b.begin, then ASCII word, then white space any, then ASCII word does, and I have a specific word, then in between -4 and 1359, or so on, then b.ref of name x, then b.fixed, and then I have a bunch of more things. So basically what I have here is a fluent interface for defining a regular expression. Now this is more verbose than the actual regular expression, but another advantage for this one is, even if I don't know, so let's say sometimes regular expressions tend to be very difficult to read. I can write a regular expression, but then readability is not that easy. This way of defining a regex also solves the problem for readability, because I can actually understand what these things are. And I can maybe add some comments and so on that would help me even more, or even give some name to a piece of the regular expression, right? Because you can also have things like templates and stuff like that. So then you can name these templates, and once you have names, it's easier to understand things. So that's a second way in which you can do an affordance. These are not the only two ways, but one of them, let's recap, one of them is basically having an alias for a more complicated command, right? Something like files.readString or new file of path.text. I just love that syntax. It's so easy. And it makes so much sense. Right? It's new file.text. It's obvious. Okay. So this would be an alias that calls some other things beneath. Or we could have fluent interfaces that help us. Even if you have a more complex context, you can guide your user into building that context before you actually, in an easy manner and in a manner that works. You don't necessarily have to read the whole manual to be able to use your API, So before we go, I'll leave you with this. This is one of my favorite websites on the internet. It's called theuncomfortable.com, and it's a designer from Athens, architect from Athens, Caterina Camprani. She created some designs that are very uncomfortable to use. Basically designs that go against against the UX principles. So you have, for example, boots rain boots that have holes in them, glasses that you cannot wear, a chair you cannot sit on, glasses, champagne glasses, two glasses that are together, so if you drink from one, you'll spill the content of the other, and so on. These are just brilliant examples of things that should not exist. And my feeling whenever I see this is again and again that these are the types of designs that we deal with every day as software developers. And the way we get over this is by understanding that software design has a user, your code bases have a user, your APIs have a user, and that user is the developer. And there are ways to improve the usability of your software designs. There are ways of improving the usability of your APIs. They don't have to be uncomfortable. Right. And if you want to learn more, I published a whole book about this, which is called Usable Software Design, and you can find on LeanPub. It's quite a short book. Maybe if there is enough interest, I will revisit it and add some more interesting things to it, because I've learned much more since that edition. With this being said, thank you kindly for the view. And until next time, remember to think, design, and work smart.